Hey, what's up, guys? This is Chung here. So today, let's take a look at this 727 minimum Windows subsequence uh, hard problem. I think this is a good one. Okay, let's take a look. So this is like another classic, like two-string problem. Basically you're given like a string S and T, and you need to find out the minimum like contiguous substring, basically substring, right? From S, where the T is a subsequence of that substring, and you need to find the minimum of that. Okay. So okay, and if there's no such window in S, then covers return empty string. And if there are multiple such minimum length windows, return the one with the leftmost start index. Okay, so not only it asks you to return the minimum length, it also asks you to return the actual string substring itself. Okay. Mm, I mean, so basically for those kind of like two-string problem, this is like I think it's pretty obvious. It's like a DP problem, right? And with those kind of two-string DP problems, there's a like certain there's a like this template. Basically, we just define the DP, right? So we just when we define the DP here, we always follow the current. We basically the we can just copy whatever the problem is asking us to do here. And so basically in this case, right, so what the dpij means what? It means that uh, starting from 0 to I, okay, and this one is from 0 to j, okay, which also like ending with I and ending with J. So the reason we need to make sure that it's ending with I and J is because we will be using the last two the I and J character, right, to do different things here. So basically the DP I and J here means that from 0 to I and also ending with I, what's the minimum constraint? What's the minimum substring, right? That's from 0 to I that contains, which is the uh, let me give you some examples how this thing works, right? Basically, let's say we have x and y, okay? X, 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 and here we have I here, and we have a y, y, y. This is j. Okay, since we're defining defining dpij means ending with I and j. Okay, and we're trying to see the value of the dpij. It means that the basically the smallest substring length, the minimum like substring length ending with I that includes the j here. Okay, so the reason I'm defining it that way is because by following the problem itself, the description itself is always usually the easiest way of defining the definition, defining the DP here. So okay, so let's say for I and J, so for all these kind of two-string problems, they're always like gonna be two cases. Basically, if the SI, okay, equals to the JI, the TI, the TJ. So so the first there are always going to be two scenarios here. So either this i's character is the same as the j's character. Okay. So if that's the case, what's going to be the DPI here? So if the current the last two characters are the same, okay, then the we okay, so then we know that okay, that's fine because I and j are the same. Then we can just try to compare what's the minimum length from here to here, right? Because we already know that I and j they're already matched. Okay, so basically this means that we can just simply do the I minus 1, j minus 1 plus 1. Remember, we're storing that like the minimum length, the minimum length of this of the dp I minus 1, j minus 1 to it. Okay, because let's say for example, let's say the minimum length that from here to here, like let's say in the case of si equals to tj here. Let's say the minimum length is 2, which means the minimum uh actually it cannot be 2 here because for the y here at least we need 3. Let's say the length is 4 for like the for the dp I minus 1, j minus 1. Okay, it means that okay, we have a length of 4 substring that can will contain like this y as a substring, as a subsequence. Then from here, right, then we know okay, since I and j are the same, then we can simply include this I, right, so that uh, this 4 plus 1 will definitely uh, include this 3y plus j because I and j are the same. That's why we can simply do a plus 1 here. Okay, else, right? So what's the else? Else means I and j is different. Okay, if I and j is different, then we have to rely on basically we have to rely on the I minus 1 dp j equals to dp, right? I minus 1, but in this case, it has to be j plus 1. Uh, oh, sorry. Oops. Did I? Come on. Uh, okay, sorry. I think I messed it up here. So, I, j. Okay. So if it's different, if it's the I and j is different, then the dp, okay, I and j will becomes what? Because since the I is not the same as j, then we cannot rely on the I to match this j here. Basically, we have to rely on everything before I to match with uh the whole target string here, which means we're gonna have like a dp uh I uh minus 1 j. Okay. Yeah. So basically, that's the case that I is not the same as j. Basically, that's the only two options here. And for the problem, let's say what if like let's say what if the from here from the dpi minus 1 there's no valid, let's say if there's no valid like substring that can match this y or either or the y plus j here, then this dpi j will be like an infinite will be going to be the infinite biggest number here, so that later on we will treat that number as like as the invalid answer. Okay, and cool. So and let me try to start coding here. I will try to explain a little bit more while I'm doing the coding here. So basically, first we're gonna have like s and n here, right? To get the length of both the s and t, and then I'm gonna define a dp, right? As I'm gonna start with the beginning at 0, okay, and then like as usual, as we do a n plus 1, right, for this thing in range n plus 1. Okay, so and then we start from I in range like 1 to what n plus 1, and then or j in range of 1 to n plus 1. Okay, so like I said, if the I minus 1 equals to the t I minus 1, we do I minus 1 because we're using like the I represent the length, which is the 1 base, but the characters for that length is 0 base. That's why we do I minus 1 here. dp I j equals to dp I minus 1 j minus 1 plus 1, else dp I j equals to dp I minus 1 j j. Oh, I think sorry, I think I made a mistake here. So we also need to plus 1 here because the dp I and j means that I mean it's it the ending like character has to be the current I here. So which means let's say we have for the else here, right? Y and j here. Even though the I and j is different, right? So for the I, if the I and j is different, so we need to use this one to tell us what's what's the rest of the length of the substring, right? That compare that can contains this entire string here. But still, since we are like we still need this I here. That's why we also we need to add a one in the end regardless, because here we're saying that okay, so this dpij means that we ending with I here. Okay, so cool. So that's that. But as you guys can see here, since we have a I minus one, j minus one, like I said, and if there's no valid, if there's not a valid answers, we need to set those values to be the biggest number. Okay. So how can we do that, right? I mean, we just need to consider like two edge cases here. Basically, the first one is the dp0j, and the second one is the dpi0. Okay, so the first one, this one means that I mean, uh, we don't have any s string here. So s string is basically is empty, but we're trying to find the all the we're trying to find a substring, right? Which means that means it's an invalid answer in that case. Okay, that's why for j in the range of 1 m plus 1 here, okay, and it means that the dp like 0j equals to the system dot max size. So the reason we're setting it to the max value is because later on we'll be doing like the minimum value here, right? So I mean, so that's why for everything that's s is empty, right? We just set it to the max size, and and when it comes down to the like this dp transition function here, right? I mean, let's say for example, if this dp I minus one cannot contains this yj here cannot contains the target string. Basically, it will go back here. This will plus one, plus one, plus one, plus one, and plus one. In the end here, right? Whenever it is empty, so here we're gonna have like a max value here. Okay, that's why I mean that's how we use this one as a base case. Okay, if okay, if there's no match for this for the substring and the target at all, in the end, this dpij will be like the max number. Okay, So, and another case is this one. Basically, for the dpi, in this case, basically the t is empty. So when t is empty, but the s is not empty, what does this mean? It means that uh, basically anything, right? So anything that any substring for ending with I will have the zero as the minimum substring length because since t is empty and the minimum substring to contain an empty string is also a empty string, right? That's why the minimum length is zero. Since we have already set everything to zero, we can just skip that part. Okay, cool. So that's how we uh, initialized our DP array here, 2D array here. But so by this time it's finished. We remember we cannot simply return the DP M and N like the other like problems. Why is that? Because right now the DP M and N means that ending with the last character. What's the minimum? What's the minimum like length that contains this T here? But but as you guys can see, the answer is B, C, D, E here, right? Which means it's ending with like this character E here. It's not ending with this one, so that we cannot simply return this. Instead, we have to do a for loop here. Basically, we need to loop through all the places, and we check if any of them, and we need to find the smallest number, the smallest length among all those kind of DP results. Okay. So to do that, we need to maintain like a current maximum length as system like max size. Okay. Okay, and then we simply gonna besides the current max length, we also need to uh, maintain like the position of this of the of the smallest length. Okay, so it's gonna be a minimum length here. Okay, of this minimum length because we need to return the like the actual string here. Okay, and then like so for I in range of 1 plus m plus 1 here. Okay, actually, since I think we can simply start from the from what from the length of t here. Okay, so why is that? Because we need at least the same length of the characters. Sorry, same length of the characters as a t here to be able to at least to do a match to have a substring that can contain everything in t here. But I think it doesn't really matter because I think we just do a start everything because for everything that's before that, right? We'll definitely have like a max number of that. So we can just simply rely on the values to help us eliminate that part. Basically, I mean the DP I and N, right? So why we do I and N here? Because since we're trying to match everything, we're trying to match the whole T here. That's gonna be our end goal, right? That's why the second character has to be N. N represents the whole T here. And I means that at each position, okay? If this length is smaller than the minimum length, okay? And then, and for those actually, so here, I think we're going to add like do a plus one here. I mean, for those, if you guys are not using like Python or Java or something, I mean a small trick here is because we're doing like plus one here. If you use this one as like a starting point, you may get an overflow. Okay, so instead we can just simply do a, s- a divided by two here. Okay, so that to make sure it won't overflow. Okay, and also here I'm gonna also do a divided by two here. Okay. But since it's Python, I think Python can automatically increase that. But I'll just do a divided by two just to be safe here. And then the minimum length will be equals to the dp I and n. And meanwhile, we also like update the 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 position of I. Okay, the position of I. Yeah, and yeah, actually the length I means the length, right? So the position is I minus one in this case. Okay, so and now we need to do a simple check here. Basically, we need to check we need to return the empty string. Basically, I mean we can do two things, right? I mean we can check if the minimum length, right? If the minimum length is like is equal to the system is equal to this, okay? And then we simply return like empty, or we can check if the position is like is equal to the minus one, then we return the empty, okay? Else what? Else we just return this, right? Since you know we have the position here, so the position is like and uh basically you know this is the ending position actually. So I mean it's the ending position, right? Because we said this I means is everything that's ending with I here. So with ending positions, how can we find that right? We just need to find the ending position minus the minimum length, okay? And the plus one, that's the that's going to be the starting point. And for the ending point, we do end point. Uh, actually, you know what? So here I'm going to do this. Yeah, position. Okay. So this will just happens to be that the last location plus one because I'm just utilizing this like the zero base and one base trick here. Otherwise, you know, since if this is like the index, the ending index, instead to get everything, including the ending index, I have to apply. I need to do a plus one here. Okay, right. But anyway, so that's that. Okay, let's try to run the code here. Hmm. Oh, sorry. So J means N, not M. Sorry. Ah, J here. Okay, cool. So this one test case passed. Let's try to submit it. All right, cool. Accept it. All right, so uh, real quick. So for the time and space complexity, I mean, I think it's pretty straightforward, right? I mean, space is of course the O of m times n, okay, and the time is also like here, right? It's also like m times n, okay. I mean, this one it's like a little bit of variation of the other like two string problem, you know, and but still it's I think it follows still following the same like template where the you just need to define like a 2D array here, 2D DP array here, and with the length plus one as the size, and then here you still follow the same template. Basically, you compare the if the I and J are the same, okay. But in this case, like the explanation is a little bit different because so if it's the same, then it means that uh, we can uh, throw the answers, right? We can throw the answers to the I minus one, J minus one, because we know the J minus one, the I minus one, they have already been matched. The I and the J character. Okay. Otherwise, we cannot throw J away. We have to also we also need to include the J because the I and J is different, so we cannot rely on the I's character to match J. We have to match everything that's ending with J with the I minus one characters. And here we do a plus one because we are maintaining the minimum length, the length of this ending with I and ending with J. Okay, and then we are doing this one to make sure we have a base case for all the invalid scenarios. Okay, and then the last thing will be once we have initialized the data we need, we cannot simply return the last one from the DP because uh, I mean the ending plate the substring can it could be end at anywhere. Okay, so that we cannot use the last ending letters here. We have to go through everything from start to the end and to find out the minimum length. Okay, that contains this all the target nth letters, and then we also like maintain this like the end position, and from the with end position and the minimum length, we can in the end we'll get the the final answers, which is the substring itself we need. Uh, cool. I think that's pretty much it is I can think about this problem. Yeah, let me know, guys, if you have any questions and if you want me to add some other explanations. Yeah, I'll be more than happy to do that. Otherwise, and stay tuned, and I'll be seeing you guys soon. Yeah, bye bye.